All right, page 2. It looks like I only get to do 2 problems, and then you're on your own converting moles to atoms, atoms to moles, moles to mass. Now, here we have an interesting problem. Nowhere in here does it say moles. It says atoms and grams. Well, I only have 2 conversions. 1 mole equals 6.02 times 10 to the 23rd atoms, molecules, particles, whatever you want to call them. And 1 mole equals the molar mass in grams of that substance. Okay, do I have a conversion to go from grams to atoms, moles to atoms, moles to grams? I do not. So this cannot be done in one step. It has to be done in 2 steps. Everything has to go through moles. So this is how I do it. Moles of Ag. So I want my answer. So basically I have to convert from grams to moles first. So I have to go from 5.35 grams of silver units, grams of silver. Up here, we're going to moles of silver. We have to go to moles first. So moles of silver, and I know that I write 1 mole, and that I know in grams of silver there are 107.9 grams in every 1 mole. And then I'm going to go from moles of silver to atoms of silver. That's what we finally want our answer in, right? Atoms of silver. And so this units have to be the same. Moles of silver, and I know that this is 1, and I know that in 1 mole of silver there are 6.02 times 10 to the 23rd atoms. So all I need is to solve this and put that answer there, and then to solve this, and that gives me my answer. So 5.35 divided by 107.9 equals 0.0495, 8, etc. I'm going to stop at 4 decimal places. I think that's reasonable. And then I'm going to multiply that times this, because we multiply everything on the top, divide by everything on the bottom, times 6.02 times 10 to the 23rd. And what I get is 2.98 times 10 to the 22nd atoms of silver. That's it. That's how you solve. If it doesn't say moles in the question, then you have to go through moles first before you can get to your answer. So right here, the next one down, I have molecules of carbon dioxide, and we want mass in carbon dioxide. So I'm starting with molecules, going to moles, and then going from moles to grams. Okay, and we're going to go convert 9.6 times 10 to the 20th molecules of CO2. So this has to be molecules of CO2 in mole CO2. Well, I know if I write mole, I write 1. And if I write mole in this conversion chart, I write 1. And I know that if I add a carbon, which is 12, plus 2 oxygens, which is 32, I get 44 grams in 1 mole. And I know that the number of molecules in 1 mole of CO2 is 6.02 times 10 to the 23rd. So now it seems like I'm all set. I have to solve this, put that answer there, and then multiply it times 44 to get me the grams. All right. So 9.6 times 10 to the 20th molecules divided by, open parentheses, 6.02 times 10 to the 23rd, close parentheses. Remember, all of that has to be in parentheses, divided by, and then 6.02 times 10 to the 23rd in parentheses, right? Yes, and then close parentheses, and then enter 0.000159. 0.00159, and then I'm just going to leave it in there and do times 44 grams per mole is 0.0701. And that seems enough grams to me. Okay, so that's how you perform a grams to atoms or molecules to grams. It's 2 steps. Just know that if it doesn't say moles somewhere in the question, that it's going to be 2 steps. So let's look at the ones you have to do. Convert moles. Atoms, moles. Grams, moles. Grams, moles. Grams, molecules. Right here, 2-stepper. Atoms, grams. Doesn't say moles, 2 steps. Got to go to moles first and then to grams. Okay? All right, let's continue with page 3. Okay. Now it seems like we're in percent composition. Percent composition is easy. It is the part times the whole. See what happens late in the day? It is the part divided by the whole times 100. I got ahead of myself. All right, so ammonia NH3 contains 82.4% nitrogen. What percentage of ammonia is hydrogen? Well, it's all the rest. So that one's pretty easy. 100 minus 82.4% equals 17.6% hydrogen. That one's easy. That's not really how we do these very often. But yeah, if you subtract out what you have, then whatever's left in that 100% is whatever you have left. All right, percent of aluminum and aluminum oxide. Okay, so it's the part divided by the whole. So I'm going to figure out what the part is first. Al is 27 per mole times 2 moles equals 54. So that is the part. And then if I add that to 3 oxygens times 16, I get the whole, which is 102 grams per mole. And if I divide that, the part divided by the whole, 54 divided by 102, enter times 100, I get 52.94%. 52.94% is aluminum. So Al2O3 is 52.94% aluminum. And again, how much sodium and sodium sulfite? So Na. So sodiums are 23 grams apiece, right? 23 right there. And I have 2 of them. 23 times 2 is 46. So the part is 46. And the whole is 46 plus a sulfur, which is 32.1, plus 3 oxygens, which are 16 apiece. I get 126.1 grams per mole. That's the molar mass of this substance. 46 divided by second answer equals times 100. 36.478% sodium. I didn't put in the times 100. I should have. Times 100 equals. There's a complete problem. Yeah, I did it in here times 100, but I didn't actually do it on here to show you what percent. Anyway, so I'm pretty sure you got those 3 dialed in. So let's keep going. I only got 8 minutes. Let's see. We can keep going here. Okay, empirical molecular formulas. Now, there's multiple ways to figure out empirical molecular formulas. The first deal is you have to figure out what you're given. What are the empirical formulas for cyclobutene, C4H4, and acetylene, which is C2H2? So if I factor, it's just eliminating the greatest common factor. If they give you a molecular formula, finding an empirical is really, really easy. I can factor out a 4, that makes this CH. Acetylene, I can factor out a 2, that makes this CH. Therefore, the empirical formula is CH. Pretty easy, right? All right, what is the empirical formula for? C8H10N4O2. I see that these are all even numbers, so I can factor a 2 out, and that's what I'm going to do. C4 divide 10 by 2, H5, divide 4 by 2, N2, and divide 2 by 2, O1. So C4H5N2O. Once you have one atom of anything, that is your empirical, because you can't factor anything out of one. All right.